Hello. I'd like to show the dot product between two vectors determines the cosine of the angle between them. And I'm going to be working in either 3 space or 2 space. So let's get started. All right, so this is what I'd like to do. Now the assumptions I will make, the assumptions is that two non-parallel vectors, non-zero, determine a line. Determine a plane, and I also will assume trig. Identities. I'll just abbreviate it. So let's go ahead and let's get started. So suppose I have two vectors. Let's call this vector A in space, and I'll draw this vector B in space. And again, the assumption I'll make here is this is not the zero vector, B is not the zero vector. And I'm drawing this as an acute angle, but it doesn't have to be. Now, because a vector, these two vectors I'm going to draw with a common point, and you can draw some point on A, and you can draw some point on B, and we'll assume that A and B are coplanar. And you can do that if B is not in the same direction or A or in an opposite direction. So we'll assume that these are non-parallel vectors. So if you can do that, what you can do is you can rotate, and we're going to call this angle theta here, the smaller of the two angles, because if it looked like this, it would be the smaller. We're going to assume that theta is between 0 and pi. So we can assume that these lie in the plane, so you can take these in space and rotate them to the plane like so. And you can draw, let's say, A like this. Now we're assuming these are in the plane. Maybe you can draw B like this. And what I'm going to do is I'm going to put the unit circle like so. And let's see, oval, okay, so we'll just do that. And just assume that's a unit circle. And I drew this as if it were, in fact, okay, this is fine. Now, what I'm going to do, this is a bit misleading. I drew B as if it were on the, I guess you could rotate this to be on the x-axis if you wish. So the first thing I'm going to do now is I'm going to note that A, the vector A, divided by its length is unit, because it's non-zero, and B, divided by its length, is unit. So you can basically, in A, you'd be, to make it unit, you'd be extending it here. In B, you might be shrinking it here. So what we can do now is we have these two things are unit vectors. So now that we know these are unit vectors, let's just focus on the unit circle, and I'm going to redraw B just a little bit. And let's look at our vectors like here from some common point. Now I might draw it like this. And then I'll erase it at the unit circle there. And make the right at the unit circle. This will be vector A. This will be vector B. Now, because this is on the unit circle, we can now write this in trig. So we can now write that A over its magnitude. Well, it has coordinates. Let's have this the x-axis, and let's call this alpha. So this could be cosine, let's see, cosine alpha times vector I plus sine alpha vector j, and then b over its magnitude, let's call this beta, will be cosine beta I plus sine beta j. You can do that because this is on the unit circle. That's the value of making it unit. Now let's calculate A over its magnitude dot B over its magnitude. Well, what that's going to be is cosine alpha I plus sine alpha j dot cosine beta I plus sine beta j. Now let's compute the dot product as we always have. And let's look at what we get on this side. Now this thing right here, this is A dot B. Since these are scalars, they can come out and then come back as something you can divide. So you take this out of the dot product. In fact, let me just do this. This is really what happens. And then we have our A dot B. And that's what this is equal to. Now, when we dot this dot product, we have cosine alpha, cosine beta, plus sine alpha, sine beta, right? Well, lo and behold, what do you have here? By the cosine and by our angle addition and subtraction formulas, this is now going to be what? We have this. This is now an angle subtraction formula. And I drew beta as positive coming here, so I probably should have written this. Well, I'll just go ahead and assume it's negative here. I drew it as negative, but it could be positive. But what is that? This is the angle between the vectors. So this is, by definition, which is what we set out to show. So thanks for watching.